Have you ever thought about whether we're truly alone in the universe or if there's more to our existence than what we see? What if the James Webb Space Telescope finally proves that we live inside a black hole? Join us as we learn more about this groundbreaking news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi movies, but the reality is even scarier. According to scientists, they're not just pitch-black holes in space. They're actually massive amounts of matter squeezed into an incredibly small area. Think of a star 10 times more massive than the Sun, all packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for centuries, ever since they pondered objects in space so massive and dense that they could trap light. The most famous ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a tiny dense core. If this core's mass is more than 3 times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no easy task since they don't emit any light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it pulls that matter towards it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can get torn apart, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, emit powerful gamma bursts, and even influence the growth of new stars in some areas, while stalling it in others. But where do black holes come from? Picture this. Stars, once magnificent and blazing, meet their ultimate demise in a spectacular explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached their celestial retirement party in a supernova blast. Smaller stars, when they die, transform into something called neutron stars, which are super dense but not dense enough to trap light. However, if a star is about 3 times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. As these mighty stars collapse, something strange occurs near their surfaces. Time itself starts to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's like the star's clock ticks at a different pace compared to ours. Sometimes, when 2 smaller black holes collide, they combine to form an even bigger and scarier black hole. If a black hole teams up with a neutron star, they create a colossal nightmare that defies comprehension. Scientists have been grappling with the scale of these cosmic phenomena for years. Black holes come in 2 sizes, huge and small. There's a sinister mystery surrounding them that we can't seem to unravel. But here's the twist. Small is relative when it comes to black holes. Stellar mass black holes, remnants of massive stars, can be as large as 10 to 24 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's an astronomical number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are on the other end of the spectrum. They are millions, if not billions, of times larger than the Sun. They exist at the center of large galaxies, including our very own Milky Way. It's like a gaping dark void that's pulling everything towards it. Renowned physicist Stephen Hawking talked about black holes in his lifetime. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of necessary equipment. However, there's hope on the horizon. A single scientific instrument is changing everything, and we're not ready for it. It goes by the name of the James Webb Space Telescope, JWST, and it's here to plunge into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to the potential of human ambition. Sure, we've launched other space telescopes before, and they've been doing their jobs just fine, but this one is in a class of its own. The JWST makes the Hubble, which has dutifully served us for years, look like a mere speck in the cosmos. The price tag of this astronomical wonder is a whopping $10 billion. Yes, you heard that right, that's enough zeros to make your head spin. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, not to mention the invaluable input from over 300 universities. But let's not forget the risks that come with such a grand undertaking. This isn't a venture for the faint of heart. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its minimum mission life expectancy of 10 years. Since its launch, the JWST has made many incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside permanently. During its journey, the telescope successfully unfolded its massive 5-layer sunshield and giant main mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is almost ready to go into full operation. One of the most exciting things about the James Webb Space Telescope was when NASA announced that it had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a match of 18 scattered bright dots from the star's light captured by the 18 mirror segments located on the primary mirror. NASA later released a new and improved image of HD 8446, in which the 18 unfocused copies of the star were brought together in a deliberate hexagonal formation. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process, bringing 18 images on top of each other into one clear view. Thanks to its sophisticated technology, the JWST will help scientists investigate the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the Epoch of Reionization. This era refers to when neutral hydrogen was reionized, or made to have an electric charge again, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are very difficult to spot because of the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more depth, including, in some cases, imaging their atmospheres. Understanding the atmospheres and formation conditions for planets could help scientists better predict if certain planets are habitable or not. Apart from studying the assembly of galaxies, scientists study galaxies to see how matter is organized on a gigantic scale. This, in turn, lets us see how the universe evolved. The spiral and elliptical galaxies we see today evolved from different shapes over billions of years. One of the JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today and the current ways the galaxies form and assemble. However, most importantly, the James Webb Space Telescope will help us answer the most profound questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around those gigantic supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the Goths of the universe. They're everywhere, from distant galaxies to comets in our solar system. They're not just fascinating because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they go all flashy and emit infrared light, a sight that can be detected by the JWST's mid-infrared instrument, MIRI. This is usually a sign that there are some hot, young stars hanging around. But wait for the plot twist. A brave astrophysicist, Ismael Garcia Bernard from Oxford University, decided to take a peek at 3 active galaxies known as NGC 652, NGC 731, and the spooky famous Stephan's Quintet, and NGC 749. These galaxies are millions of light years away in the depths of darkness. Now, what Garcia Bernard discovered will make your hair stand on end. In those central regions where the black holes reign supreme, he found an abundance of PAHs. Sounds good, right? Well, here's where it gets chilling. The radiation near those supermassive black holes twisted the PAH's very essence, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into oblivion. Imagine being devoured by the darkness itself. But wait, there's a glimmer of hope. The larger PAHs managed to survive because they found shelter within thin, dense, gas-filled clouds. It's like they found their own protective cloak against the horrors of the black hole's wrath. Now, you might wonder why this dark twist matters. Well, you see, it's a bit of a conundrum for astronomers who rely on PAHs to track star formation. Star-forming regions tend to be all charged up with electrically charged PAHs. If those molecules are obliterated near the black hole cores, tracking where those stars are born becomes a real challenge. But fear not, our fearless astronomers aren't backing down. Garcia Bernard and the gang are planning to dive even deeper into this dark cosmic abyss. They want to analyze more active galaxies, each with its own twist, to uncover the secrets of how these tough PAHs survive in such terrifying conditions. They're on a mission to unravel the specific properties of PAHs lurking in the black hole-infested cores of galaxies. That knowledge is the key to understanding star formation and how these eerie galaxies evolve over time. But there's another discovery made by the James Webb Space Telescope that takes the cake. Get ready for some spine-chilling news, because the JWST has detected what could be the oldest black hole in the universe. This cosmic monster is a supermassive black hole weighing a whopping 10 million times more than the Sun. The JWST was able to identify it by analyzing faint glimmers of light that date back to the very beginning of time itself. This dark, ominous discovery was found at the heart of a baby galaxy, just 570 million years after the universe was formed. And get this, astronomers believe that there could be even earlier black holes lurking in the depths of space. It's fascinating yet terrifying to think about what other horrors could be hiding out there, waiting to be discovered. But one thing is for sure, the James Webb Space Telescope is giving us a glimpse into the darkest corners of the universe, and the things we're finding are nothing short of mind-bending. The discovery of the oldest black hole in the universe has sent shockwaves through the scientific community. This cosmic monster could just be one of many black holes that existed during the cosmic dawn, a period that started about 100 million years after the Big Bang when the universe was just a billion years old. Astronomers are baffled by the sheer number of these black holes and how they grew to such colossal sizes. Although the researchers who discovered the latest black hole published their findings on the preprint server AR-14, the research is yet to be peer-reviewed. Led by study author Rebecca Larson, an astrophysicist at the University of Texas at Austin, the team believes that there could be many more black holes waiting to be found. She explained that the James Webb Space Telescope is allowing us to study cosmic history in a way that was previously impossible, and she's excited to see what else we'll discover. The mysteries of the universe have long captivated human imagination and scientific inquiry, prompting countless questions about our place in the cosmos. With the advent of powerful observational tools like the James Webb Space Telescope, we stand on the brink of revolutionary discoveries that could redefine our understanding of reality. One of the most intriguing aspects of the universe is the relationship between black holes and galaxy formation. The existence of supermassive black holes at the centers of galaxies suggests a complex interplay between these enigmatic entities and the galaxies that host them. Recent studies indicate that black holes may not only consume surrounding matter, but also influence the motion of stars and the dynamics of their host galaxies. This gravitational interaction can regulate star formation, leading to the creation of a more organized galactic structure. The JWST's ability to observe galaxies in their early stages offers scientists a unique window into this process. By examining light from these distant galaxies, researchers can glean information about the conditions that prevailed shortly after the Big Bang. This epoch is crucial for understanding how the first galaxies formed and evolved, eventually giving rise to the diverse universe we see today. The JWST can capture data from galaxies that existed billions of years ago, providing insights into the fundamental processes that shaped cosmic history. In addition to investigating galaxies, the JWST is also designed to study the atmospheres of exoplanets. By analyzing the light that passes through a planet's atmosphere as it transits in front of its host star, scientists can identify chemical signatures that indicate the presence of potential biosignatures. This groundbreaking work could lead to the discovery of planets that possess the right conditions for life, igniting debates about our place in the universe and whether we are alone in this vast expanse. Furthermore, the JWST's mid-infrared capabilities allow it to explore regions of space that are typically obscured by dust. This enables astronomers to peer into stellar nurseries, where new stars are born. By studying these areas, scientists can better understand the life cycle of stars and the conditions necessary for their formation. The intricate dance of stellar evolution, from birth to death, is a fundamental component of cosmic history, and the JWST plays a pivotal role in illuminating these processes. Another significant aspect of the JWST is its potential to observe cosmic events such as gravitational wave mergers. These events, resulting from the collision of black holes or neutron stars, create ripples in spacetime that can be detected by observatories on Earth. By correlating these gravitational waves with electromagnetic observations from the JWST, scientists can gain a more comprehensive understanding of the processes involved in such cosmic phenomena. As the JWST continues to unveil the secrets of the universe, it challenges our understanding of time, space, and the very fabric of reality. Each new discovery raises additional questions, prompting a re-evaluation of existing theories and encouraging a spirit of inquiry. The pursuit of knowledge is a driving force in humanity's quest to comprehend the cosmos, and the JWST stands as a testament to our relentless curiosity. With its advanced technology and ambitious goals, the James Webb Space Telescope is set to redefine our cosmic narrative, paving the way for future explorations that may one day answer the profound questions about existence that have long intrigued humanity. What lies beyond our current understanding remains a thrilling mystery, inviting us to look deeper into the universe and, ultimately, into ourselves. The James Webb Space Telescope is on a mission to uncover the unfathomable, and who knows what other mind-bending cosmic surprises await us in the vast expanse of space. The universe is full of mysteries just waiting to be unraveled, and with each new revelation, we inch closer to unlocking its dark and startling secrets. What do you think the JWST has in store for us?